Hello everyone, and welcome to this tutorial. In this video, we'll be looking at using first-order differential equations to describe the rates of change of mixtures. So as an example, we have a brine solution that is pumped into a tank containing 1000 litres of water at a rate of 1 litre per minute, and the well-stirred mixture leaves the tank at the same rate, and we've been told to let x as a function of t be the amount of brine in the tank at time t. And for part A, we've been asked to show this differential equation where dx by dt is equal to 1 minus x over 1000. So if x of t denotes the amount of brine in the tank at any time, then dx by dt will be the rate at which this amount of brine changes at any given time t. Now the rate at which the amount of brine in the tank changes will depend on two factors. This will be the rate in and the rate out. So dx by dt, the overall change, will be the difference between the two, so rate in minus rate out. And we can see in the question that the brine solution is pumped into the tank at a rate of 1 litre per minute. So the rate in is equal to 1 litre per minute. But now the rate out, well, this will be the concentration of the brine in the tank at time t multiplied by the rate at which it is leaving, or the outflow rate. So the concentration of brine at time t, well, we know there's x amount at any given time, and we know that it's leaving at the same way as entering, so the amount won't change overall, and this is given as 1000. So the concentration will be x over 1000. And the outflow rate, well, we're told it is leaving the tank at the same rate at which it is entering. So again, this is 1. So this is x over 1000. So now we have the outflow and the inflow. We can say dx by dt, the overall rate of change, will be the rate at which it is coming in minus the rate at which it is leaving. And this is the differential equation we were asked to find. Okay? So now for part B, we've been asked to find the concentration of brine in the tank at time t. So this is the same idea as what we did here. We need to work out the amount of brine in the tank, so we need to know what x is as a function of time, and we know that the overall amount in the tank will be 1000. So we need to think about working out x as a function of time. And we can work out x by solving this differential equation. And in a previous video, I showed you how to solve equations like this using an integrating factor. And this is where we start by writing the equation in this form. We have dx by dt plus p as a function of time times x. And this will be equal to q as a function of time. So to start, we need to move this x over 1000 to the left-hand side. So now we have dx by dt plus, and I'll split up this x over 1000 as 1 over 1000 multiplied by x, and this is equal to 1. So q is 1 and p is 1 over 1000. And the integrating factor will be e raised to the power of p integrated with respect to t. And we know that p is 1 over 1000. So we need to integrate 1 over 1000 with respect to t, and this will be 1 over 1000 t. So when we raise e to this power, we get e to the power of 0.001 t. So now we need to multiply every term in this differential equation by this integrating factor. So we get dx by dt times e to the 0.001t plus 1 over 1000 multiplied by the same integrating factor multiplied by x is equal to e to the 0.001t. And now we can use the reverse product rule. where the derivative of e to the 0.001t is this function, and the derivative of x is dx by dt. So now we can simplify the left-hand side as d by dt of e to the 0.001t multiplied by x is equal to e to the 1,000th of t. So this is exactly what we have here, just with this left-hand side simplified using the product rule of differentiation. So now to find out what x is, we need to integrate both sides with respect to t. So e to the 1,000th of t multiplied by x will be equal to the integral of e to the same power integrated with respect to t. And when we integrate this, we use the reverse chain rule. Sorry, just 1 second. This is 0.1t. And when we integrate this, we use the reverse chain rule. So this becomes 1,000 e to the 0.001t plus the constant of integration. Okay, so at this point, we can't go any further until we work out this constant, but we're told in the question that the tank contains 1,000 litres of water, so the amount of brine initially in the tank is 0. So we can say that when t equals 0, the amount of brine x is equal to 0. And then we can substitute these two values into this equation. So we get e to the 0 times x is equal to 1,000 e to the 0 plus c. And this x is also 0. So the left-hand side is 0. This is 1. So c must be equal to negative 1,000. And now we can put this value of c back into here. So e to the 1,000th t times x will be 1,000 e to the 0.001t minus 1,000. So now we can divide both sides by e to the 1,000th t. So we're left with x is equal to 1,000 e to the minus 1,000th t. And we can factorize out this 1,000. So we get the amount of brine in the tank at time t will be 1,000 lots of 1 minus e to the negative 1,000th t. Okay, so this is the solution to a differential equation, but our question asked us to work out the concentration. And the concentration will be this amount of brine in the tank. So the concentration will be x of t, the amount of brine in the tank at any time, divided by the total amount of liquid in the tank, which is 1,000. So we have x as a function of t divided by 1,000. These two will cancel. So our solution is 1 minus e to the negative 1,000th t. Okay? Okay, so thank you for watching. I hope that's given you a clearer idea on how to model mixtures using differential equations. If you did find that helpful, please like the video and subscribe to the channel. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.